This is my fully 3D printed Rover. In this video I'll be talking about my development and prototype process and show off my latest design. Hey everyone, welcome back to another project video. The fully 3D printed Rover idea was first conceptualized back in March when I had the idea to fully 3D print an RC car. The whole point of this project was to develop a vehicle capable of off-roading and driving on grass and dirt, as well as to test the durability of 3D printed gears, wheels, and axles. The history of this project is full of failures and disasters, and iterating on design after design took weeks of CADing and 3D printing. Most of this project was actually sitting at my computer troubleshooting SOLIDWORKS errors. Anyhow, here's a brief rundown of the different iterations. Iteration 1 was a four-wheeled car. The geared ratio from the motor to the output was 1 to 103, which was a bit too slow. Fortunately, I had the foresight to split the car in half, consisting of the drivetrain half and the steering half. The steering half was left mostly unchanged from here on out. This is the first test of the gearbox, and the first official drive of the vehicle. Iteration 2 is also a car, with a solid rear axle but with a slightly better gearing which made it go faster. However, the weak point of the drive system was still the rear axle, only 8mm in diameter to fit the bearings I had on hand. This meant it couldn't take much torque and it just snapped a lot. Iteration 3 was the first tricycle design. I got frustrated with messing with axles and stuff, so I went with only one wheel in the back that was going to be belt driven. However, the gearing was only like 1 to 8, which was a little too high, so that ultimately didn't work out. Iteration 4 was the first planetary gear set that I had designed. This ultimately suffered from instability. The outer tire only had contacted the bearings at 2 points, so the rings slipped off a lot. Also, the gears only had one bearing each, which led them to being driven off the drive mechanism a lot. Since there was only one bearing in this gear, it would have a tendency to drive itself off like this, and then it would get stuck. This was a big problem, so eventually, instead of only having one bearing in each gear, upgraded to something like this, which has two bearings, and this keeps the entire gear centered. And so you can actually see that in my final design. So there's one bearing right here in this rear gear, and on the other side, there's another bearing in this little housing right here. All that being said, this was the first design that I was happy about because I was actually able to drive it around. Iteration 5, the current design, features 3 points of contact where the bearings ride in the ring's grooves. Thus the tire should never fall off. It uses 12 standard skateboard bearings just in the drive mechanism alone, and an additional 4 up front for the wheels puts the total at 16. The gearing is approximately 1 to 33 and features hunting gear ratios. Gear ratios at each stage are non-integers, so the gears will theoretically wear out less quickly. Now let's talk about some of the features of the car, starting with the wheels. This is one of the front wheels of the Rover. The intent of these chevrons was to provide some spring force, and so ultimately that didn't really work out because they would just break instead when I hit things. But it's better than having a solid wheel, I think. There's still some compliance in it, and it features 2 skateboard bearings, one on each side, and so they spin pretty true. And the wheels just slide onto these axles as so, and then there's just a little washer to keep them on. And I've never had a front wheel fall off, so that's good. The back wheel is held on with bolts, which makes it easily serviceable. The 2 carriers are held together by these axles, which is what the gears ride on. And to prevent the axles from sliding off, I have pins and 3D printed washers. To remove components from the gearbox, you just have to bend the paperclip pin and take it off like this. And just for fun, here are all the 3D printed prototype pieces and failed prints. Now onto the electronics that powers the car. It's a pretty bare-bones setup with one servo controlling the steering, which is Ackerman geometry, a motor, a speed controller, and a receiver. This is the servo I originally had on it, which is a 13-gram Metal Gear servo, and this actually wasn't powerful enough, and so the gear's stripped in it, and you can't really move it. You can hear the sound it makes. That's not a good sound, so. I eventually upgraded to the super beefy and overkill 10 kg/cm 55-gram servo, which will probably break the steering mechanism before it breaks itself. The 120 amp car ESC that I'm using is meant for 1/8 scale vehicles, and the current drawn by the car even at high accelerations remains under 10 amps, so it's complete overkill. but it enables me to drive backwards and use higher cell batteries such as this 4-cell battery. The motor is a 2212 980 kV brushless motor which is rated for around 300 watts maximum. The gear reduction reduces the RPMs of the motor from up to 16,000 RPMs to around 500, which results in a theoretical 13 mph top speed. Given that I'm able to reach up to 12.3 miles per hour on grass, I think that result is pretty good. The car is able to drive on a bunch of different surfaces such as grass, wood chips, and dirt. The gear system is really robust even when wood chips prevent the ring from turning. A little nudge is all it needs to keep driving without any issue. You might have noticed that the car has a tendency to tip a lot, mostly because there's no suspension and the car isn't very wide, because I intended to drive it at lower speeds where these variables wouldn't really affect performance. And that's pretty much it. This was a fun little project and a great learning experience. Despite being initially designed for lower speeds, I'm glad there aren't major instability issues at higher speeds of 10 miles per hour or more. Overall, I'd say I'm happy with this performance. There's little to no wear on the original gears despite months of driving, and its acceleration and overall performance on grass is still great. Thanks for watching, and if you enjoyed, don't forget to subscribe.